Hello guys, welcome to my channel Science to Scientist. Today we are going to start our first chapter of physics of class 9, that is motion. Before that, let's know the basic terms in the motion chapter. A reference point. A reference point is used to describe the location of an object. An object can be referred through many reference points. Knowing about the second term, that is origin, the reference point that is used to describe the location of an object is called origin. For example, a new restaurant is opening shortly at a distance of 5 km north from my house. Here, the house is the reference point that is used for describing where the restaurant is located. Knowing about the motion, if the location of an object changes with time, the object is said to be in motion. Knowing about the motion in a straight line, distance. The distance covered by an object is described as the total path length covered by the object between two endpoints. Distance is numerical quantity. So we do not mention the direction in which an object is traveling while mentioning about the distance covered by the object. So now let us examine by an example. As there are four reference points, that is O, A, B and C. Here O is located at 0, A at 60, B at 35 and C at 25. The distance is in kilometers. If we have to go to C from O, we can choose various paths. That is from O to C, or from O to A and then back to A to C, or to going from O to B and coming back to C, from B to C, or going to O, from O to A, coming back to B and coming to C. So in this we can see the distance covered will be shortened or increasing as per our distance covered, whether we are taking any of the paths. So knowing about the displacement, the shortest possible distance between the initial and final position of an object is called displacement. In the previous example only, as the points were located as O, A, B, C, in this the shortest distance between the point O and C will be 25 kilometers, as it is the smallest distance between the starting point and the final point. The displacement depends upon the direction in which the object is traveling. That is, this you can easily understand that in which direction it is been going on. And the displacement is denoted as del x. And del x is represented as xi minus x naught, where xi is the final position of the object and x naught is the initial position of the object. Knowing about the zero displacement, when the first and last position of an object are same, displacement is called zero. As if in another example, if we consider we are going from our home to a school and coming back from home to school, means school from to home, then the displacement we are making is zero, as the total distance covered between our starting point and the final point is zero. The example can be considered below again, that is we are moving on a path that is in a square shape having 5 meters each side. That is A, B, C, D are the 4 points of the path. In this we go 5 meters from A to B, then B to C, then C to D and D to A. So in this we are covering the distance of 20 meters, but the displacement we can see here is 0 meters. So this is called the zero displacement. Knowing about positive displacement and negative displacement, these are in which the displacement is made in negative direction is called negative displacement, or the displacement made in positive direction is called a positive displacement. This can be illustrated by an example. Suppose from a point that is from varied in kilometers is from 0 to 12 kilometers. In this, the point is located, A point is located at 0, and whereas B point is located as 12. And the B point moves from 12 kilometer, that is at 12th point, to the 6th point. So in this, the displacement made is 6 kilometers, and this is represented as negative as it is coming from a higher value to a lower value. So that will be a negative displacement. Whereas a positive displacement, if we consider the point A moves from 0 to 6th point, that is considered it C. So here the displacement is in positive direction. So this would be called a positive displacement. So talking about the next topic, so what are scalar and vector quantities? The scalar quantity describes a magnitude or a numerical value, whereas a vector quantity describes the magnitude as well as the direction. Hence, the distance is a scalar quantity and the displacement is vector quantity. As in the distance, we are not knowing in which direction we are going, or either that is in straight line or in a curved path or any way. Whereas in displacement, it is fixed that we are going in a straight line, or we are going in an inclined way or in a declined way, but it is always in a straight and we are always knowing its direction. So now let us quickly tabulate the difference between distance and displacement. The distance provides the complete details of the path taken by the object, whereas the displacement does not provide the complete details of the path taken by the object. The distance is always positive, whereas displacement can be positive, negative or zero, as we have seen in the above examples. Now distance is a scalar quantity, whereas displacement is a vector quantity. The distance between 2 points may not be unique, whereas the displacement between the 2 points can always be unique. Now let us quickly have a question on this. That is, a farmer moves along a boundary on a square field of side 10 meters in 40 seconds. So what will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds? So the answer would be the distance covered by the farmer in 40 seconds will be 40 into 1 meter, equivalent to 40 meters. And the speed of the farmer, that is distance by time, equals 40 meter divided by 40 seconds, making it 1 meter per second. So the total time given in the question that is 2 minutes 20 seconds, that is equivalent to 2 into 60 plus 20, that is 140 seconds. So the total complete time is 140 seconds. Since the complete one round of the field is 40 seconds, so he will complete the 3 rounds in 120 seconds, that is, or 2 minutes. So 120 meter distance is covered in 2 minutes, and in another 20 seconds he will cover around 20 meters. So total distance covered in 2 minutes 20 seconds will be 120 meter plus 20 meter, making it 140 meter. Now the displacement would be root 10 raised to the root 10 square plus root 10 square. That will be making it root 200 as per the diagram we are seeing over here. That is making it 10 root 2 equivalent to 10 into 1.414, making it 14.14 meters. So the displacement we got is 14.14 meters. Moving to another question, that which of the following is true of for displacement? The A is that it cannot be zero, and the second is that its magnitude is greater than the displacement traveled by the object. So here the both A as well as B are false with respect to concept of displacement, as the displacement cannot be zero, or the magnitude is greater than the distance traveled by the object. Moving to another topic, that is uniform motion and non-uniform motion. So what is a uniform motion? When an object travels equal distance in equal intervals of time, the object is said to have a uniform motion. Whereas talking about the non-uniform motion, when an object travels unequal distance in equal intervals of time, the object is said to have a non-uniform motion. Knowing about the speed of an object is defined as the distance traveled by the object per unit time. Its SI unit is meter, and the symbol of representation is meter per second, or ms raised to the power minus 1. Speed is equal to distance by time. It can also, we can know its relation by the triangle law, that is keeping the D at top, S at left and T at the right at the in the bottom. In this we move anti-clockwise, that is from, we know the anti-clockwise direction. In this, if we want to know the D, we will be simply writing S into T, as both of them are in bases. The bases are always written in the multiple form, whereas if at the top and bottom is considered, then it is kept in divided form. And if we want to know the speed, we will be getting it distance by time. Whereas if we want to know the time, we will be getting distance by speed. So you can clearly see in the figure of the triangle law. Now, knowing about the average speed, if the motion of object is non-uniform, then we calculate the average speed to signify the ratio of motion of that object. So you can clearly understand through this definition. The average speed relation can be written as the total distance traveled by the total time taken. Now consider an example. If an object travels 10 minutes in 3 seconds and 12 minutes in 7 seconds. So then what is the average speed would be? So here the total distance traveled is 10 meters plus 12 meters, making it 22 meters. Whereas the total time taken, that is 3 seconds plus 7 seconds, making it 10 seconds. So here the average time would be the total distance traveled by the total time taken. So we will be writing it 22 by 10, making it 2.2 meter per second. That is, in each second, the object is traveling 2.2 meters. Now, to describe the rate of motion in a direction, the term velocity is used. It is defined as the speed of object in particular direction. Velocity is displacement upon time and the SI unit is meter, whereas the symbol of representation is meter per second or ms inverse. Knowing about the speed with direction, that is the average velocity in the case of uniform motion and average velocity in the case of non-uniform motion. In the case of uniform motion, the average velocity is equals to initial velocity plus final velocity whole divided by 2. Whereas in non-uniform motion, the total displacement by total time taken is called the average velocity. Moving to another question, that is, what are instantaneous speed and instantaneous velocity? The magnitude of the speed or velocity at a particular distance of time is called instantaneous speed or velocity. Considering a few of the questions, that is any speed, distinguish between speed and velocity. So the answer would be the speed of a body is the distance traveled by it per unit time, while the velocity is displacement per unit time of the body during movement. The second question could be, under what conditions the magnitude of average velocity of an object equals to its average speed? The distance traveled by an object is equal to the displacement, then the magnitude of average velocity of an object will be equal to its average speed. Moving to the third question, that is, what does the odometer in an automobile measure? So the odometer of an automobile measures the distance covered by that automobile. Moving to the fourth question, that what does the path of the object look like when it is uniform motion? So the answer is quite simple, that is, graphically the path of an object will be linear. That is, looks like a straight line with it is in uniform motion. Moving to the fifth question, during an experiment, a signal from a spaceship reached the ground situations in 5 minutes. So what was the distance of the spaceship from the ground station and the signal travel at the speed of light, that is 3 into 10 to the power 8 meter second inverse. So the answer is the distance is equal to speed into time, making it 5 minutes into 3 into 10 to the power minus 8 meter per second inverse, making it 5 into 60 seconds into 3 into 10 to the power minus 8 meter per second inverse. Now that is making it 300 seconds into 3 into 10 to the power 8 meter second inverse, making it 900 into 10 to the power 8 meter second inverse, or equal to 9 into 10 to the power 10 meters, or we can simply say it 9 into 10 to the power 7 kilometers. Knowing about the rate of change of velocity, first we will let us know about uniform motion. In case of uniform motion, the velocity of an object remains constant with change in time. Hence, the rate of change of velocity is said to be 0. Talking about non-uniform motion, in case of non-uniform motion, the velocity of an object changes with the time. This rate of change of velocity per unit time is called acceleration. Here, acceleration is the change in velocity by the time taken. That here the SI unit will be meter per second squared. The uniform acceleration, that is, an object is said to have a uniform acceleration if, first, that is, if travels in a straight path, And second, if the velocity changes, that is increases or decreases by equal amount in equal time interval. Knowing about non-uniform acceleration, an object is said to have a non-uniform acceleration if its velocity changes, that is increases or decreases by unequal amounts in equal time intervals. Acceleration is also a vector quantity. Please note over there, the direction of acceleration is the same if the velocity is increasing in the same direction. Such acceleration is called positive acceleration. If the direction of acceleration becomes opposite as that of velocity, and if velocity is decreasing in direction, such acceleration is called negative acceleration. Knowing about deceleration or retardation, negative acceleration is also called deceleration or retardation. Now, considering few of the questions on this topic, that is, when will you say a body is in, first, that is uniform acceleration, or second, in the non-uniform acceleration. So we will be saying a body in a uniform acceleration when the object travels in a straight line at its velocity changed by equal amount in equal intervals of time. It is said to have a uniform acceleration. Whereas we will be saying a body in a non-uniform acceleration when it is called the variable acceleration, when the velocity of an object changes by unequal amounts in equal intervals of time. It is said to have a non-uniform acceleration. Considering the second question, it is, a bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. So find the acceleration of the bus. So answer is quite simple, that is, initial speed of bus is 80 km per hour, that is 80 into 1000 divided by 60 into 60 seconds, making it 200 by 9 meter second inverse, that is equivalent to 22.22 meter per second. So the final speed of the bus, that is V, is equal to 60 km per hour, making it 60 into 1000 by 60 into 60 seconds, making it 50 by 3 meter second inverse, or 16.67 meter inverse. So here the time we have been given in the question is 5 seconds. So acceleration, that is A, is equal to V minus U by T, making it 16.67 minus 22.25 by 5, which is equal to 5.55 by 5. And as it is, the U value is greater, so it will be in negative. That is minus 5.55 by 5, making it minus 1.11 meter per second square. Considering the third question, that is, a train starting from a railway station and moving with uniform acceleration attains a speed of 40 km per hour in 10 minutes. So find its acceleration. So since the train starts at the rest, from rest, that is U will be 0, and the final velocity of the train will become 40 km per hour, that will be our V. So here V will be taken as 40 into 1000 divided by 60 into 60 meter second inverse. So that will be 400 by 9 meter second inverse, equivalent to 11.11 meter second inverse. So the time taken is 10 minutes. So converting it into seconds, that is 10 into 60, making it 600 seconds. Since acceleration is equal to V minus U by T, so here we know that U is 0 and V is 11.11. So we can directly write that 1.11 meter second inverse by 600 seconds. It will make it 0.018 meter second per square. Now let us know the graphical representations of motion, that is, first of the distance time graph. So it represents the change in position of the object with respect to time. The graph in the case of the stationary, that is, means the distance is constant at all time intervals. The straight graph parallel to x-axis will be formed. You can clearly see in the figure. The second graph, that is the graph in case of uniform motion, we will be getting a straight line graph. You can clearly see the graph that is plotted between the distance or time. In this, the time is taken in the x-axis and the distance is taken in the y-axis. And the graph which is plotted over here is inclined at 45 degrees. Now the third graph, that is the graph in the case of non-uniform motion. The graph has different shapes. That is, you can see over here that the graph is continuously moving up and down, this graph is also plotted between the distance and the time, taking the time at x-axis and the distance at y-axis. Now knowing about the second type of graph, that is velocity time graph, first let us know about the constant velocity. The straight line graph, velocity is always parallel to the x-axis, whereas the uniform velocity or uniform acceleration, that is, we'll be getting a straight line graph. So first let us see about the uniform velocity graph for the uniform velocity between v by t. So here we can see a straight line that is parallel to the x-axis, and the second graph, which is of uniform acceleration, we can see the graph is inclined at same as the graph which we have seen in the case of uniform motion. It is also inclined at 45 degree. The non-uniform velocity or the non-uniform acceleration graph can have different shapes. This graph is also plotted between v and t. So here the graph is in non-uniform velocity, and it is continuously, its shape is changing, as we have seen the graph in the non-uniform motion. Now calculating the displacement from a velocity time graph. Consider the graph given over here. The area under the graph gives the distance traveled between a certain interval of time. Hence, if we want to find out the distance traveled between the time interval t1 and t2, that is over here from that is 5 and 11, we need to calculate the area enclosed by the rectangle ABCD, where the ABCD is equal to AB into AC. Similarly, to calculate the distance traveled in a time interval in case of uniform acceleration, we need to find out the area under the graph, as shown over here. To calculate the distance between the intervals t1 and t2, we need to find out the area represented by ABED. So the area of ABED is the area of rectangle ABCD plus the area of triangle ADE, making it, that is, area of rectangle will be AB into BC, whereas area of triangle ADE will be half into AD into DE. So by this we can find both the areas enclosed by a graph which is parallel to x-axis, whereas another graph that is inclined at 45 degree from the x-axis. Now knowing about the equations of motions, the equation of motion represents the relationship between an object's acceleration, velocity and distance covered if and only if, first, that is, the object is moving on a straight path, second, the object has a uniform acceleration. Now knowing about the three equations of motion, first let us quickly see the formulas. That is, the first is the equation of velocity with the time relation, velocity time relation, that is v equals u plus at. The second relation, that is the equation of position time relation, that is s equal to ut plus half at square. Whereas the third equation, that is for position velocity relation, is 2as equals v square minus u square. So here in these above three relations, here the u is initial velocity, a is uniform acceleration, t is the time, v is the final velocity, s is the distance traveled in time t. So now let us derive the equations of motion graphically and seeing each one of them briefly. That is the first we can see over here in this graph. Let us study the graph above. That is, the line segment PN shows the relation between the velocity and the time. So initial velocity u can be derived from velocity at point P or by the line segment OP. So the final velocity v can be derived from the velocity at point N or by the line segment NR. Also, NQ is equal to NR minus PO, making it V minus U. So the time interval T is represented by OR, where OR equal to PQ, which is also equivalent to MN. So first, deriving the equation for the velocity diagram relation, we will let's see about it. So the acceleration is over change in velocity by the time taken. So the change in velocity is the final velocity minus initial velocity by time. That will be making acceleration as a, final velocity as v, initial velocity as u, and the time as t. So at equals v minus u, that making a v as u plus at. Now deriving the second equation for the position time relation, We know that the distance traveled by an object, area under the graph. So the distance travel of area, that is the area of OPNR, equals area of rectangle OPQR plus area of triangle PQN. So here S will be equal to OP into OR as the area of triangle, plus the second, that is that was for rectangle, and for triangle, that is PQ into QN by 2, making it S equals U into T plus T into V minus U divided by 2. That will make it S equals UT plus half AT square, because we know that AT equals V minus U. In the above equation, we can see in the first equation we have found out that. So we can clearly get S as UT plus half AT square. Now deriving the third equation, that is the position time relation, we know that the distance traveled by an object equals the area under the graph. So here the S equals to the area of OPNR, which is the sum of parallel sides into height by 2. So here S will be equal to PQ plus NR into PQ by 2, making it V plus U into T by 2. So 2S equals 2S divided by V plus U will become T. That will be, let us consider it equation 1. And also we know that V minus U by A equals 2. So let us consider it second equation. So now on equating equation 1 and 2, we get that 2S by V plus U equals V minus U by A. Now 2AS equals V plus U into V minus U. So this is clearly as A plus B into A minus B, making it A square minus B square. So this will become 2AS equals V square minus U square. Now considering about the uniform circular motion, if an object moves in constant velocity along a circular path, the change in velocity occurs due to change in direction. Therefore, this is an accelerated motion. Now consider the figure given over here, and let us observe how directions of an object vary at different locations on a circular path. So here we can see the directions of different paths while on circular motion. Now talking about the uniform circular motion, when an object travels in a circular path at uniform speed, the object is said to have a uniform circular motion. The non-uniform circular motion, when an object travels in a circular path at a non-uniform speed, the object is said to have a non-uniform circular motion. Example of uniform circular motion, that is the motion of satellite in its orbit, or the motion of planets around the sun. The velocity of uniform circular motion, that will be the velocity equals distance by time, making it circumference of circle by the time, that is V equals 2 pi r by t, where the V is the velocity of the object, r the radius of circular path, and t is the time taken by the object. Now let us consider a question on this, whatever we have just talked about, the relation of the or the velocity of the uniform circular motion. That is, an artificial satellite is moving in circular orbit of radius 42,250 km. Calculates its speeds if taken as 24 hours to revolve around the Earth. So the answer would be, let us assume an artificial satellite which is moving in circular orbit of radius 42,250 km. Covers the distance S as it's revolve around the Earth with speed V in given time t of 24 hours. So that is 42,250 km. Now the radius of circular orbit, that is r, equals 42,250 into 1000 meters. So the time taken by the artificial satellite will be t equals 24 hours, making it 24 into 60 into 60 seconds. So the distance covered by the satellite S, we are keeping the time taken as this only, as in further when we will be simplifying it, it will be easier to cut it easily. Now talking about the next, that is this distance covered by the satellite, that is S, is equal to circumference of the circular orbit, making it 2 pi r. Now the speed of satellite, that is V equals 2 pi r by t, making it 2 into 22 by 7 into 42,250 into 1000, whole divided by 24 into 60 into 60. So that will be making it 2 into 22 into 42,250 into 1000, whole divided by 7 into 24 into 60 into 60 in meter second per inverse. That will make it 300,073.74 meter per second, making it 3.073 kilometer per second. So all this we have studied about all things in the motion. By this we have completed our today's lecture. If you like this video, please don't forget to like it, subscribe it and share it. And feel free, or if you have any doubts, please just write in the comments.